For nearly a decade, one technology separated SpaceX from every other launch company on Earth. It wasn't a bigger rocket. It wasn't a more powerful engine. It was the ability to bring a rocket home and fly it again. That one breakthrough transformed the economics of spaceflight. While other countries were building new boosters for every mission, SpaceX was reusing the same hardware over and over. The result was lower costs, faster launch schedules, and an enormous lead in the global launch market. But that lead just became harder to defend. China has successfully recovered an orbital-class rocket booster for the first time. Instead of using landing legs like Falcon 9, engineers recovered the booster using a sea platform equipped with a catching system. It marks China's biggest step yet toward reusable launch vehicles. At first, it sounds like another rocket test. It isn't. Because this isn't about one launch. It's about who controls the future of access to space. To understand why this matters, we need to go back to how rockets have always worked. For decades, launching a rocket was like buying a brand new airplane for every flight. The engines lifted the payload into space, and then they were gone forever. It worked, but it was incredibly expensive. SpaceX looked at that system and asked a simple question. What if we stopped throwing the rocket away? It sounded unrealistic. The first landing attempts ended in explosions. Then came hard landings. Then came controlled touchdowns. Today, Falcon 9 landings happen so often they've become almost routine. That success changed the industry. Launching became cheaper. Customers came in larger numbers. SpaceX built an advantage that nobody else could match. For years, every major space program watched from behind, China included. China never hid its ambition to build reusable rockets. Its engineers studied different recovery methods while developing new launch vehicles for future lunar missions. Now they've reached a milestone. During the latest test, the booster completed its mission, descended toward an offshore recovery platform, and was successfully captured instead of being destroyed. That's important. Recovering the booster is only half the challenge. The next step is proving it can be inspected, refurbished, and launched again. That's the point where real savings begin. One detail makes China's approach especially interesting. They didn't simply copy Falcon 9. Falcon 9 lands on deployable legs. China chose a different solution. Their recovery system removes the need for heavy landing legs by using hooks and a catching platform at sea. Every kilogram saved on landing hardware can be used for payload instead. That may sound like a small engineering choice. It isn't. Rocket design is a game of kilograms. Saving weight almost always improves performance. Whether this approach becomes practical over dozens of missions is something only time can answer. But it shows China isn't chasing yesterday's technology. They're building their own version of reusable launch systems. So why should anyone outside the space industry care? Because reusable rockets don't just save money. They change how often you can fly. A cheaper rocket means more launches. More launches mean more satellites. More satellites improve communications, navigation, and Earth observation. The same launch vehicles can also carry supplies for lunar missions, scientific equipment, and eventually, astronauts. Every reduction in launch cost creates opportunities that were previously too expensive. That's why every major space power wants reusable rockets. Not because they're impressive, because they're economically powerful. This also changes the conversation around the moon. The Artemis program depends on frequent launches. China's lunar program does too. Neither country is planning a single mission. They're planning years of missions. Habitats, cargo deliveries, power systems, communication satellites, surface vehicles. Every one of those requires rockets, lots of them. The country that launches more often gains experience faster. The country with lower launch costs can sustain a larger program over time. That's where reusable boosters become strategically important. Before anyone declares that China has caught SpaceX, it's worth keeping the numbers in perspective. SpaceX still leads by a wide margin. Falcon 9 has completed hundreds of successful booster recoveries and reflights. That experience cannot be replaced overnight. China has completed one successful recovery of this system. That's a milestone, not the finish line. The next challenge is consistency. Can they repeat it next month? Can they recover another booster after that? Can they reduce refurbishment time? Can they make reuse economical? Those questions will determine whether today's achievement becomes a turning point or simply an impressive demonstration. History shows that breakthroughs rarely change the world overnight. The first reusable rocket landing didn't make SpaceX dominant. Repeated success did. China now begins that same journey. If this recovery system proves reliable, launch costs could fall. Mission frequency could increase. and China's ambitions for the moon become much easier to support. That's why engineers around the world were paying attention to this test. Not because one booster came home, because it might be the beginning of an entirely new launch capability. For years, reusable rockets were considered America's biggest advantage in space. Today, China took its most significant step toward closing that gap. The race isn't over. SpaceX still leads, but the distance between first and second may have just become a little smaller. The question now isn't whether reusable rockets are the future. That's already been answered. The question is, how quickly can China turn one successful recovery into a fleet of reusable launch vehicles? Because if they can, the next decade of the space race could look very different. If you enjoyed this breakdown, let me know your thoughts in the comments. Is China genuinely closing the gap, or does SpaceX still have an untouchable lead? Don't forget to subscribe for more engineering deep dives into the technologies shaping the future of space exploration.